Though the use of solar panels is on the rise, it still only represents 1.5% of total energy consumption in Europe. There are several reasons for this, starting with the intermittent nature of solar energy due to bad weather, the difficulty of storing it, and the cost of solar panels. Researchers in Neuchâtel in Switzerland are working on ways of making solar energy more cost-effective. This includes using less precious metals in their manufacturing and new technology to better absorb sunlight. We have two solar panels here. One is older generation, the other new generation. So what's the difference?
There are two fundamental differences. One is visible, the other isn't. The visible one is here. You can see on this cell 3 copper strips which are used to extract electricity. Then there are several strips of silver. In this case there are many strips of copper and far less silver strips, so you save 5% in production costs. That's the difference. The second is invisible. Here we added a nanometric layer of silicon which increases voltage by 15%, thereby increasing performance by 15%.
Are there other advantages?
This generation of solar panels in the sun heats up, but performance drops at a slower rate than with this other type of panel at half the rate, which means we produce more kilowatts per hour.
After it's been built, the solar panel undergoes resistance tests. This is the hail test. 4-centimeter wide balls of ice are launched at the panel at a speed of 27 meters per second. Researchers are particularly interested in how the panel's thin layer of silicon will stand the shock. Once the artificial hailstorm is over, the panel's performance is measured again to see if it could take it. Then comes the weight test. Metal bricks weighing more than 12 kilos each are stacked on the panels until the load reaches 1,000 kilos per square meter. The idea is to simulate strong winds and heavy snow. This will allow engineers to select the right material for building the panels. In addition to the reliability tests, we also carry out tests on the panel's electric performance, which are very important because they allow us to calculate how much electricity the unit generates. In order to do that, we use light tables like the one you can see behind me, which simulates the sun's spectre and allows us to measure the unit's electric efficiency. That kind of measurement allows us to establish whether there's any manufacturing defect, especially when it comes to the electric connections. People often say solar panels are ugly. Researchers in Neuchâtel have created this panel called terracotta, a color which would match the roof tiles of many houses in European cities. Researchers are convinced that new, more efficient and less costly technology will help make solar panels a force to be reckoned with on the global energy market.